Let's go over algebra, which you will find in first paper. So things you need to know is things such as like terms. So like terms are terms that have the same variable and also raised to the same power, but the coefficient, which is the numerical part, can be different. And unlike terms are terms that are very different in terms of the variable, or also in terms of the power that they are raised to. So let's look at the examples here. These two are like terms because they have the same variable to the same power. These two are unlike terms because they have different variables. These two are like terms because they have the same variable to the same power, but these two are unlike terms because they have the same, they might have the same variable, but they have different powers. Then over here, again, same variable, same power, different variables. Here, same variable, same power, same variable, but different powers. And then here, same variable, same power. The problem here is that one is a variable with a coefficient, whereas the other one is just a constant. So things that you can do to variables, like terms, you can add them and you can also subtract them. Okay, then we move on to factorizing trinomials in the form of x squared plus bx plus c. So if we're factorizing, there's two ways we can do it. We can either follow this method at the top, or we can follow the bottom. So this one says step one, find two numbers which are going to be in P and Q, so that when we add them together, they give us B, and when we multiply them together, they must give us C. So the nice thing here, let's look at this formula. We have 12. We're going to find factors of 12. We have 2 times 6. We have 1 times 12. And we have 3 times 4. We have factors of 12. Yes, when we multiply them together, they do give us 12. Now we want to know which one, when we add them together, they will give us 7. So we have 6 plus 2, which will give us 8, 12 plus 1, which will give us 13, and 3 plus 4, which will give us 7. But we're not looking for a negative 7, we're looking for a positive, another positive 7, but we're looking for a negative 7. So we can use negative 3 multiplied by negative 4 to find a positive 12, and we can say minus 3 plus a negative 4 to give us a negative 7, and plus the factors here, for us, P and Q would be negative 3 and negative 4. Then they say write the expression so that the middle term is split into 2 terms, which is P and Q, and factor by anything. So you could do that, or you could just realize that these are factors, and you just write them out, x minus 3 and x minus 4 is equals to 0. Or you could go ahead and take that approach, and sometimes can be a little bit. So the next way we can do it is just to put them into this equation here. That I'm showing you right now, that our A with regards to the equation we have at the top would be A, our B would be negative 7, our C would be a positive 12, and you can plug them in here, and you should get, say, like this. The next thing we're going to look at is properties of exponents. Right? We have product of power. When we are multiplying two exponents together, we can add them. This is only if the bases are the same. We have the power of a power. If we have a power to a power, then we multiply them. And we have a power of a product. This means that this m, which is the exponent, belongs to both the A and the B. Then we have negative exponent. So here we have a to the power of minus m. We can make our a to the power of m a denominator so that then our m becomes positive. This is as long as a is not 0. Anything to where we have the 0 exponent, which tells us that anything to the power of 0 is equal to 1, only if a is not equal to 0. We have the quotient rule that tells us that if we are dividing two exponents, then we can minus them, and we have the power quotient. So again, that belongs both to the and when it comes to logarithms and exponents, remember we can change between exponent equation to a log equation over here, where your a becomes your base. So this is your base, it comes from there, and then you're solving it with regard to x, and y now becomes your input. And this is for a that is greater than 0. A cannot be equal to 1, nor can y be equal to 0. We have an example here where we have 2 to the power of 5 is equal to 3. We can change it to log base of 2, and with an input of 2 represents output of 5. Then we come to solving quadratic inequalities. When you have a quadratic inequalities, the first thing we're going to do is find the roots, right? So we can find the roots either using the quadratic equation or the method that I just showed you now. Here they found the roots. They found that the roots were a minus 1. Okay, in this case, it's a plus 1 and a plus 3, and there we are. And you can tell by the value of a that we're going to then have a smiley face. So it's looking for where our graph is positive, which is now going to be the blue part over here. And this means that x needs to be either less than 1 or greater than 3 for us to have positive y values. Over here, we still have the same equation, but we are looking for where the y values now are going to be less than 0. If we look at our graph, we'll see that they exist between the values of 1 and 3. So then we will write that x is between 1 and 3, so that we can get y values that are less than 0. To get and to see more practical work of what we've been talking about right now, you can head on to the Fundamental YouTube channel, where you can watch several videos that go over both your IEB and your questions. See you in our next lesson.